So welcome back Math 2 students. So this video is on Module 5 remediation, segments in a triangle. If you remember, there was several segments in a triangle we talked about. The first one being a median. Okay, now a median is a segment that goes from the vertex to the midpoint of the opposite side. And there's one important thing you have to know about this. When this segment, this median, goes from that vertex to the opposite side, right? This point here ends up being the midpoint. And if this point ends up being the midpoint, what do we get out of that? We get two congruent segments. So what do we do with the measures? You're basically going to set the measures equal to each other. Okay? So from that, we go from a median, right, to an altitude. And an altitude is a segment that goes from the vertex perpendicular to the opposite side. Now, as we said before, an altitude can be inside or outside the triangle, right? In an acute triangle, all of the altitudes end up being inside the triangle. So if I draw all of these altitudes, right, all of those land inside. Now, in a right triangle, the leg of the right triangle is an altitude, the other leg of the triangle is an altitude, and then the final one you can draw goes from the right angle perpendicular to the opposite side. Okay, now an obtuse triangle, one of them is easy to draw, and that's that altitude. But what you have to understand is the other ones will lie outside. So what I have to do is extend this side, and then I can drop this altitude down. If I want to go from this vertex to this side, I'm going to extend this side, and now I can drop the altitude there. But the number one thing you have to get from an altitude is that it gives you a right angle. All right. Now, perpendicular bisector is a segment that's perpendicular to a segment at its midpoint. It could also be, instead of just a segment, it can be a line or a ray also. But the thing is, this definition does not say it has to go from a vertex. So basically, I find the midpoint of a side, and I draw a segment perpendicular to it. So those are congruent, and I get a right angle. If I wanted a perpendicular bisector of this side, find the midpoint, so those are congruent, and then draw a segment, line, or ray perpendicular to it. So every triangle can have three medians, right? One from each vertex. It could have three altitudes, and you could actually have three perpendicular bisectors. So let's look at the first example here. It tells us EC is a median of triangle ABC. So this here is a median. And if you remember, the definition of median goes from a vertex to the midpoint of the opposite side. So as soon as I look at this, E is the midpoint, I know these segments are congruent, and that's what I'm going to use to find the value of x. Now, what do I do with these two measurements, right? Well, since I know E is the midpoint, these are congruent, I'm going to set them equal to each other. And now I'm going to subtract 3x. I'm going to add 10 to solve this equation. 6x equals 18, right? Now divide by 6, and x is equal to 3. Okay, now it's asking to find the length of AB. So what do I have to do to make that happen? I'm going to come back here, plug this value of x in. So 9 times 3 minus 10 gives me 27 minus 10, which tells me this is 17. Since these are congruent, this is 17. So AB is equal to 17 plus 17, which is 34. Okay? So you have to know that median gives you two congruent segments. These other measurements are what we call distractors, right? They force you to know which segment lengths to use. So in example 2, right, tells you segment BC is an altitude. Remember, altitude goes from a vertex perpendicular to the opposite side. So right now, if it's perpendicular to the opposite side, what you have to know is this is going to be a right angle. And what do we know about right angles? Right angles are 90 degrees. So I don't know anything about these segments. They're not congruent. These are the distractors in the problem. The only thing you need to know is that 3x minus 2, this angle measure, is going to equal 90 degrees. So when I add the 2 to both sides, nope, not 92, 2, I get 3x equals 92. And now when I divide by 3, okay, what does that end up being? X ends up being approximately 30.67. Okay, now they are asking for the measure of AC. Well, here's the thing. This is the hypothetical measure of AC. So what we're going to do is take that value of X and plug it in. Okay, and when I do that, 30.67 times 2 minus 5 gives you about 56.34. And that would be the length of this segment. So you have to know this is what you found. Okay? Now, the last example here, right? DE is a perpendicular bisector. So as soon as I see this, I'm going to draw this down. And I know it's a perpendicular bisector, so these are right angles. And then I'm also going to mark E is the midpoint, which means AE is congruent to EC. Now they tell us one more piece of information here. AC is equal to 20 units long. Now what is to find Y? Let's find Y first. In order to find Y, what I have to know is this is where Y is, and that represents an angle measure. And what do we know about that angle? It is equal to, 3y plus 6 is equal to 90 degrees. Now I can solve for y. Subtract 6, 3y equals 84, divide by 3. 84 divided by 3 gives you y equals 28. Now, to find x, what you have to understand is they tell you this is 2x plus 4. But remember, E is the midpoint. So if this whole segment is 20, if I take 20 and I divide it by 2, this segment's 10 units long, this segment's 10 units long. So all I have to do is take AE, I know that's 10 units long, and they tell me the measure of AE is 2x plus 4 equals 10. Now I can go ahead, solve for x, right? Subtract 4. Now I'm going to divide by 2, and x is equal to 3. Now they want me to find the measure of BC. That's this here. Well, what variable do I need to know to find that measure? I need x. What's the value of x? 3. So 3 plus 5 gives us what? 8. So BC is equal to 8. All right, go ahead and try the homework. And if you have any questions, just let me know.